The final section for chapter 1 adds in absolute values. Absolute value is kind of like a car wash. If your car is dirty and you go through the car wash, it makes it clean. If your car is clean and you go through the car wash, it's still clean. Absolute value turns whatever's inside positive. Of course, if it's already positive, then it just stays positive. So we're going to look at doing absolute values and then tie that back into the last section where we're going to look at solving inequalities that also have absolute values. Now, the thing to understand about an absolute value is, since whether it's positive or negative, it's going to make it positive, we have to consider two cases anytime we want to solve an absolute value. For example, if the absolute value of x equals 5, then x could be 5, or x could be negative 5. And it is that two possibilities that we always have to consider. So, for example, 2a minus 1, the absolute value of 2a minus 1 equals 7. So, one of the situations we'll set up will be just as written as if there was no absolute value bars in the problem. The second one will be written this way, because in fact, if 2a subtract 1 did equal negative 7, the absolute value bars would make it be positive 7. So always solve for the positive case and the negative case. So here, go ahead and add 1 to both sides. Divide by 2. And so there is one of our answers. And here, and there is our second answer. So, in general, absolute values will give us two answers. Now, as you'll see, as we progress, they won't always be true, but as a general rule, that's pretty good. Now, if we have a situation like this, we treat it very similar to the way we did with the square roots in our equations. That is, we need to have everything that is not the absolute value on the other side. In other words, we're not going to do the two cases with the setup as shown. We have to first have the absolute value equal a number, and then we can do the two cases. So now we can go ahead and do the positive case and the negative case. So adding 3, 5x will equal 10. So x is 2. Over here, 5x will equal negative 4. So x is negative 4/5. And of course, you can see plugging them back in. If I put in 2, that would be 10 minus 3, 7. Absolute value of 7 is 7. If I put in the negative 4 over 5, the 5s would cancel on and have negative 4. Subtract 3, which is negative 7. Absolute values make that positive 7. So, two cases. All right, number 3, we're going to do the same thing we did in number 2. We're going to move that 9 over. So we subtract the 9 from both sides. And I don't have to do anything else. This is a no solution. Why? Well, absolute value is always positive. So a positive number cannot equal a negative number, because I got a -8 there. So there is no way to make that absolute value equal a negative number. So it is possible to have a no solution when I solve. All right, here's a case where I have absolute values on both sides. Still going to do the two cases. First, as if there wasn't any bars at all. And second, the negative. And note what I did here. I put a negative for the whole thing, not the A, not the B, the whole thing. Because it's that whole 8 minus B that could be negative, that the absolute value would then make positive. Now we can go ahead and solve. Well, here, if I try to move either B to the other side, they'll cancel out. And I'm left with 7 equals 8, which is not true. So that's not going to provide me with any answer. Okay, here, let's go ahead and distribute. Now I can move my B's and my 8. So I'm going to get and so in this case, only one solution. Yeah, here's another one. Just in case you were curious, this one had the variable as the second part of the term. What if the variable is the first part of the term? But again, we're going to do the same thing. Over here, again, doesn't matter if they're first. We end up with something that is not true. In the second case, so I will end up with one answer again. So it does not matter if I have the same magnitude, if you will, the same number of the variable on both sides. It does not matter whether they're first or second. All right, one last example here. Now I've switched it. It's first here and it's second there. So here's my first example. So I'm moving things around. I'm going to end up with 2m equals 4, or m is 2. And the second one, now I'm going to do the negative example. So now my m's go away when I try to move it from one side to the other, and I end up with something that's true. -2 equals -2. True. So no variable is left, which means my answer is all real numbers. So I can end up with two answers. I can end up with a no solution. I can end up with situations that have only one answer. And I can end up with all real numbers, depending on the situation. Now, it turns out because I am having two possibilities in all of these, if we go back to the top for a moment, this is where it brings in the compound equation. In other words, a situation in which more than one thing is true at the same time. So, let us take a look. Even though I have the absolute value, which will give me two different possibilities. Now I'm also bringing in the less than symbol. So a little bit different here. First, the positive case, and then the negative case. And note what I have done here. The positive case kept the symbol, the less than or equal to, just as it was. But the negative case, I have to switch the less than into a greater than. Now I can go ahead and solve. Let's see. Subtract 5, divide by 2, subtract 5, divide by 2, so I have to be smaller than 1/2, which will be right in here. I'm going to use brackets because I have lines underneath. And I got to be bigger than negative 9/2, which is almost, well, it's 4.5, so almost 5. And so here's what the graph would look like. As interval notation, this will be if I wanted it more in a set notation, I could have also done it as and here is our compound equation. It is greater than or equal to this and less than or equal to the negative 1/2. All right, next, absolute value. And just as we did before, we're not going to do things unless we have the absolute value all by itself on one side. So the very first thing we would do is that. Now I can write out my two possibilities. So again, kept the sign for the positive case, flipped the sign for the negative case. Now we can go ahead and solve. Add 3 gives 12 divided by 4. 12 divided by 4 will be 3. Here, add 3 will give us negative 6 divided by 4. which actually is 3/2. So we're going to do that here. We've got to be bigger than 3. Also, no line underneath, so it's a parenthesis. 1, 2, 3. So bigger than 3. And less than basically 1.5. So in set notation, or in interval notation, this one will look like union of those two. Again, a compound equation. All right. Here we're going to move the 5. What do you think? I got -3 is greater than the absolute value of 7y minus 1. This is a no solution. Why? Negative can't be greater than a positive. So we would have a problem there. So in this case, no graph. All right, similar problem here. Going to move the 5 over. 4 minus the 5 will give me -1. Now, note, no matter what x I put in here, the absolute value is going to make this positive. Any positive number is bigger than -1. So this one is actually all real numbers. Every positive is greater than -1. Now, since it's all real numbers, what would this look like on a graph? Well, basically, and in interval notation, from -infinity to +infinity. So, note, 4 situations, we can end up with 2 areas, or actually 1 area in between. Note, less than gave us an in-between case. Greater than gave us 2 different areas that could solve this. If I end up with the absolute value less than a negative, I will get no solution. And if I end up with the absolute value greater than a negative, then I get all real numbers. And the entire graph is marked. And so that wraps up chapter 1.